to the countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good evening to all teachers, parents and the wonderful student. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia with the hashtag Bermula Percuma, Selamanya Percuma. Before we proceed, let's begin our session today by recitation of the Ummul Kitab Al-Fatihah for the Muslim and a moment of silence for the non-Muslim. Al-Fatihah. So how is everyone doing today? My prayer that everyone is in the best of health and ready to proceed with today's class. Before we start, let me introduce myself first. My name is Nun binti Muhammad Nun. You can call me Madam Nun. I am lecturer from College Matrikulasi Negeri Sembilan and I am your moderator for today's class. The most important person today is our passionate and fantastic presenter, Madam Rosmaya. She is a very experienced teacher from SMJK Yuhua, Kajang Selangor. So let us give a warm welcome to our presenter today. For a record, we are now live on Madam Rosmaya channel. So as a sign of support to Madam Rosmaya for the hard work in preparing today's lesson, please subscribe her channel. Okay. As usual, the lesson will last approximately 1 hour. The certificate link and the credit claim link will be given at the end of this session. Remember that you can only use e-Didik email to claim the certificate. For the credit claim, you need to collect the 1 letter and 5-digit code which will be announced separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. I will also like to remind students, if you wish to post comment in the chat box, please use appropriate language and use appropriate profile picture. I am pretty sure all students here are excellent students who will uphold a positive classroom environment. Please give your full cooperation in making this class a lively one. Do stay focused, and if you have any question, please write on the chat box and we will try to provide you with the answers. Before I give to Madam Rosmaya to present our class today, I will announce the first digit code for the credit claim. The first letter and 2-digit code is A31. A31. Okay? A31. Alright. So without further ado, please welcome Madam Rosmaya to start her presentation. Okay, Madam Rosmaya.
Okay, hi everyone. I am Madam Rosmaya. So I will guide you all through this live session on the topic magnetic fields. We are going to solve 11 questions, okay, given already earlier down in the description part below and also in the chat box. Okay, so before I begin, I would like to introduce the pre-U team in Academy YouTuber. Okay, so the physics team, okay, lead by me, okay, and Madam Nom is one of our member, okay, Madam Nom. Okay, the other member is Teacher Apsayu and Teacher Su. Okay, we also have Mathematics T team, okay, lead by Teacher Im. And Biology Pre-U lead by Cikgu Faiza. And Chemistry Pre-U lead by Cikgu Shahnon. Perakaunan and Ekonomi Pre-U lead by Madam Fizi. Okay, Academy YouTuber also has apps. You can download from the Google Play Store. Okay, there are a lots of video, PDPC video you can get from there. Okay, including our physics video. Okay, now we come to the main topics for today. Okay, we are going to do revision on magnetic fields. Okay, part 2. Another 11 question to be solved. Okay, I hope you all have done all the questions given before. So today we will discuss the answer. Okay, for question 1. Okay, so we read the question together. Okay, two long straight wires are fixed parallel to one another a distance d apart. So the wires carry equal constant current I in the same direction. So the attractive magnetic force per unit length between them is F, okay, small letter, equals to F capital letter per length. So what is the force per unit length between the wires if their separation is 2D and each carries current 2I? Okay, so given the answer here A, B, C, D. So which one is the answer? So those who have done, you can write down in the chat box so that we can see together whether your answer is correct or not. Okay. So from the statement given here, same direction, okay. So same direction of currents mean the two wires will experience an attractive force. Okay, will experience an attractive force. So if there are different direction current, the wires will experience a repulsive force. Okay, they will repel each other. So that's mean this one, they will attract here, but given already in the question here. So the formula we are going to use is this one. Okay, force per unit length is given by mu naught I1, I2 per 2 pi r. R is the distance between the two wires. Okay, so there are two situations given. So the first one will be mu naught I because I1 and I2 is the same, so we can use I squared here per 2 pi d. So we use d here because given 2d for the second situation. So that's mean the first situation it must be d. Okay, so for the second situation you substitute 2d and 2I for the current and also distance r. Okay, so now we can use ratio to solve, to see the relationship between F and F prime here. This is the F for the first situation. So second situation is F prime. We don't know F prime. So we can cancel out mu naught 2 pi I and D. So I squared and D. So the answer 2 squared is 4 divided by 2 is 2, then cross multiply. So we get F prime equals to 2F. So therefore the answer is D. So those who can get answer D, okay, congratulations. But I didn't see you write in the chat box there. Okay, so congratulations those who can get the answer 2D, 2F, 2F, the answer D. Okay, so next we go to question 2. Okay, if you have any question, you can write there in the chat box also. Okay, so now we go to question 2. Okay, question 2, we read the question together first. Okay, two long parallel wires each carry the same current I in the same direction. Okay, given in the diagram here. So what is the total magnetic field at the point P midway between the wires? So this point P given is midway between the wires. So that's mean that the distance from the upper wire is equals to the distance from the lower wire. Okay, so we still use the same formula. This is force per unit length for the straight wire. Okay. But the question doesn't want force. The questions want magnetic field. So many students confused between these two formulas. So be careful. The questions want magnetic field. So now we use this formula. Okay, so this formula is for straight wire, B of a straight wire, B of a coil, and B of a solenoid. So for this case, we use the first one, okay, B for a straight wire because this is a straight wire. Okay, now to determine the direction of the B, okay, because the questions want total magnetic field. So it is understood that the questions actually want B net or B resultant. B resultant. Total magnetic fields mean B resultant. Okay, so we use a grip, right hand grip rule to determine the direction of B from the first wire and also for the second wire. Okay, so we grip, so that's mean at point P here, the direction of the B is tangent to the direction to the electric field, not electric field, magnetic field circle here. Okay, so at point P is a cross, okay, into the screen. Okay, for the upper, for the lower bottom, for the bottom wire, okay, we use grip rule also. So the magnetic field direction at the center here, middle of the wire, this midway, point P. So it's out of the screen. Okay, out of the screen. So that's mean they are opposite of each other. Okay, the B for wire, the lower wire, and B for the upper wire is opposite direction with each other. Okay, both have same magnitude of B because the I and D is equal. Equal. So I in the same direction and same current. So I and D are equal. So that's mean the B into the screen, let's say we put it as negative, mu naught I per 2 pi D. And the B out of the screen we use as positive, mu naught I per 2 pi D. So that's mean we substitute into here, we get this. So that's mean the total magnetic field is 0 at point P. So to see mathematically, okay, so we can write like this, the total of B, use vector. So B into plus B out of the screen. So when we substitute together with the negative sign to show direction of the B, one is into the screen, one is out of the screen. We can see clearly here, mathematically is equals to 0. So the answer is total magnetic field is 0 at point P. Okay. Next, we go to question 3. Okay, you can also, because sometimes in the question they ask you to draw. Instead of drawing like this, you can also draw side view like this. Okay, so if you watch or observe from here, side view, so the B direction is like this. One is to the right, the other one is to the left. Okay, they are equal in magnitude, so the resultant is 0. Okay, now we go to question 3. Okay, question 3. Okay, those who can get the answer and just come to watch this live session, okay, and have done the question, so you can write there in the chat box. Okay, now question 3 we read together. So two wires carry currents in the same direction as shown below. Okay, where are the points where the magnetic field is 0? Okay, so now this question you must be very careful because now the currents are no longer the same like the previous question. Okay, for question 3, the current for the upper wire is 2 ampere and for the lower wire is 8 ampere and their distance is 5 centimeter apart. Okay, you must know the conditions for the B resultants to be 0. Okay, the first one, both B are equal in magnitude, but they are in opposite direction. Okay, this is what you need to know. And then another one, the formula we are going to use. So the formula for a straight wire, so we use a formula for a straight wire which is B equals to mu naught I per 2 pi D. Okay, we use Ampere's law to derive all this question, if you can remember from the previous discussion. Okay, so we use again a grip rule to get the direction of B. Okay, at the top of the wire here is dot. Okay, in the middle here is cross. Okay, because it's into the screen. Okay, sorry for the noise just now. Okay, so in the middle here, center between the two wires is a cross to show the direction of the magnetic field at this point. At the top is out of the screen, okay, using grip rule. But don't forget, we have also another one at the bottom here, for larger circle. Okay, for larger circle, at the point here, it also has B direction into the screen. Okay, 3 position here. Okay, remember that B opposite direction. B for the condition B to be resultant to be 0, both must be opposite direction. So we jot down here 3 possible places for the direction of the B at these 3 points. Okay, so same as the bottom wire here. So we do the same. So this one will be out, and here cross, shown by the green cross here, green dot. And don't forget the top one also dot. So that's mean the opposite direction B shows by both shows in the middle here. So that's mean on the top and at the bottom here, this one is out of the, not the possible answer lah, not the possible answer. For the magnetic field to be 0, so both are in opposite direction. So that's mean it happened somewhere in the middle here. Okay, it happened somewhere in the middle between these two wires. It is impossible for the B resultant to be 0 outside these two area. Okay, from these two area. So it's impossible because they both, you see, dot dot cross cross. So that's mean out into the screen. So cannot be. The resultant cannot be 0. Okay, now for the distance from the middle here, we don't know yet. So we just assume to be X. So the other distance from the lower wire will be 5 minus X, because the separation is 5 centimeter. So 5 minus X. Okay, now we can use this formula. Okay, so you form 2 equations of B, one for the first wire, top wire, and the other one is from the bottom wire. So for the top wire will be mu naught, current is 2 ampere, and then 2 pi x, the distance here is x. And then for the bottom wire, mu naught, 8 ampere here given, and then 2 pi, and distance is 5 minus x. So both must be equal in magnitude for the B resultant to be 0. So you equate these two, B top equals to B bottom, and you solve for x, you get the answer. Okay, so cancel mu naught, cancel 2 pi, cross multiply, and you get x equals to 1 centimeter. So where is the 1 centimeter? Here in the middle, and below the upper wire. Because this is x, right? 1 centimeter. So below the upper wire. Okay, so that's the answer. Okay, next we go to next question is now what if the 2 wires is in opposite direction? Just now, look at the question 3 is same direction. So if opposite direction, so where is the point where the magnetic field is 0? Okay, so let's try. We use the same concept. Okay, conditions for B resultants to be 0. So remember that both B are equal in magnitude but in opposite direction. Okay, so we use still this formula because it's a wire. Okay, so you grip the wire. Remember, got 2 position and one more, don't forget, at the bottom position. Okay, now for the bottom wire, you use right hand grip rule to determine the direction of B. So the 4 fingers here, okay, it curl the wire in this direction. So in the middle here, cross, and the bottom will be out of the screen. So don't forget the other one on top, okay, for bigger circle. Okay, so there are 3 positions. So now you see we have 2 positions which both be in opposite direction, top and bottom. So we choose, so it's impossible for the B resultant to be 0 between these 2 wires. Okay, it's impossible because it's cross and cross. So it's impossible. Okay, so for the B resultant to be 0 must be either on top or at the bottom. So we check on top first. Okay, distance, let's say X, and for for the another one is 5 plus X for the bottom wire. For the bottom wire, 5 plus X. So again, we use the formula and form 2 equations. Okay, B top equals to mu naught 2 per 2 pi X. Okay, for the first wire, and for the second wire or bottom wire, mu naught, current is 8 ampere and the distance to this position is 5 plus X. Okay, now you equate them. Okay, remember the conditions. B are equal in magnitude. Okay, now you cancel the same, the mu naught and the same magnitude. 2 pi cancel 2 pi and cross multiply and you get X 1.67 centimeter. So where is the X you mark just now? So there, so that's mean it's above the upper wire. So 1.67 centimeter above the upper wire. Okay, so that's the answer. Okay, now we try the bottom one, the bottom here. Okay, just now we do the top one. So remember there are difference in magnitude current. So it may be possible for the bottom also or maybe not possible. So we need to try. So for the bottom one, we do the same. Okay, now let's say the distance from the wire here Y and the other one will be 5 plus Y from the top wire. 5 plus Y. Okay, so we form 2 equations. Okay, for wire 2 ampere, the distance is 5 plus Y here, current 2 ampere. And for the bottom wire, so mu naught 8 ampere current and the distance from the position here is Y. So you equate them and cancel mu naught and 2 pi and cross multiply. So you get Y is negative, so it's not possible. So it's not possible for the, because you get negative answer. Okay, so question 4, only one position. The answer is 1.67 above the upper wire. So at this position only. Okay, so we go to question 5. Okay, so question 5, we read the question together. Solenoid P has a length L, cross-sectional area A, and N turns. Solenoid Q has a length 2L, cross-sectional area 2 ampere, and 2N turns. So which solenoid has the greater magnetic fields at its center when equal currents are flowing through them? Okay, so which one? Whether P, Q, or both have a same magnetic field, or none of the above are correct. Okay, so let's check. Remember that the formula is, for this is solenoid. Okay, for solenoid, the formula is B equals to mu naught and I. B magnetic field for the solenoid is mu naught and I. Okay, so we use this formula and form two situation from the 2 situation given. So mu naught, N is a number of turns density. So N turns length L. So number of turns density is N per L and then times I, the current. Okay, the second situation, now the number of turns 2N and number of and the length is 2L. The length 2L. So you substitute into here. Current is the same. Okay, equal current. Okay, equal current. So current is the same. So you see these two can cancel out. You get same answer. Okay, same for both situations. So that's mean they are not, the B is not depends on the cross-sectional area. A. So it's only depends on N and I. So they have same B. The answer is C. Okay. Both have same magnetic field. Okay. So okay, Chaya, I can see I can see your message there. Okay. So number 5 is C. Both have same magnetic field. Okay. So you can imagine like this. One has number of turns N and the length L. The other one number of turns is 2N and the length also and the L becomes 2L. Okay. But the B is the same. Okay, be at the center of the solenoid, same. So it doesn't depend on the cross-sectional area. And the name given for B is not just magnetic field strength, but also magnetic flux density. They have same meaning, magnetic field strength and magnetic flux density. So magnetic flux density doesn't depend on the area, but magnetic flux itself depends on area, cross-sectional area. Magnetic flux density doesn't depend. So usually the terms that has like resistivity or conductivity or density, so all these it doesn't depends on the like magnetic flux density doesn't depends on the area. Like resistivity doesn't depends on the length of the wire. Okay, resistivity of the wire. And what else? Conductivity. For the copper, even you cut the copper into few pieces, it still have the same conductivity. Okay. Okay, so we go to the next question. Okay, Chayao. Very good. You've tried the question. Okay, now we go to question 6. Okay, what about your answer? Those who have done this question can write there in the chat box. Let's join this live class session. You are supposed to have done the question. It's more proper way to do revision. Actually, you've done first and then we discuss here. Okay. So now we go to question 6. Let us read the question together. Okay, a wire carrying a current is at one end of a solenoid carrying a current as shown in the figure. Okay, this is a wire, this is a solenoid. So the current direction is given in this position and this is a straight wire. So the direction of the magnetic force on the wire is, okay, Chia, try B. Okay, so let's check whether your answer is correct or not. Okay, so you use right hand grip rule to determine the direction of B. Okay, so you grip the solenoid. So the current direction shows by the 4 fingers here upward. So therefore the B shows by the thumb is in this way. Direction is this way to the left. To the left. Okay, so next you use Fleming's left hand rule. Okay, so B is to the left. Okay, B is to the left. And then current for the straight wire now, for the straight wire. So B is, current is downward. Okay, current of this straight wire is downward. So therefore the force, the force is into the screen. Okay, the force is into the screen. Okay, so that means the answer is into the screen or into the plane of this slide. Okay, so first you use right hand grip rule to determine the B experienced by this straight wire. So this wire, straight wire, experience B from the solenoid. Okay, from the solenoid. So the B experienced by this straight wire is to the left. So using Fleming's left hand rule, you find that the F force is into the screen or into this slide. So the answer is C. Okay, good try, Chayao. So now we go to...
Okay, Madam Rosmaya, can we take a break? Okay, would you like to take a break for a while for the advertisement? Okay, class, we will see the advertisement.
Berita baik untuk semua. Kini, Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, hi everyone. So before we continue, I will announce the third digit code for the credit claim. So please listen carefully. The third digit code is number 1. Okay, the third digit code is number 1. Okay, so Madam Rosmaya, you may proceed with your presentation. Okay.
Okay, thank you, Madam Nun. Okay, so welcome back, students. So it's raining here at my place. I hope the rain doesn't disturb the sound system. Can the sound system okay or not, Madam Nun?
Yes, okay, very clear and cannot hear the raining or the storm or whatever. Very
Okay.
good, you can continue.
Okay, thank you, Madam Nun. Okay, so we continue with question 7. Okay, a long solenoid carrying a current produces a magnetic field B along its axis. So if the current is half and the number of turns per centimeter is double, so the new value of the magnetic field is, okay, now it's solenoid, yeah. So remember, it's a solenoid. So formula for the solenoid, magnetic field for the solenoid will be B equals to mu naught and I. Okay. So using this equation, the given situation also, there are two situations given. So you can form two equations. So the first one, let's say we use N and I, okay, initially. So the second situation, half. So that means the N is double. Okay, the N is double to N and the current is half, right? So the current is half. So half I. So now you can use ratio to see their relationship. So 2/1. So 2/1 also BF per BI. And then mu naught 2N half I per mu naught and I. Okay. So those who get the answer can write there in the chat box before we come up to the final answer. Okay, cancel mu naught and then N and then I. Okay, 2 per 2 is 1. So this means BF equals to BI. So they have same magnetic field. Okay, so which is given B here. So BF equals to BI equals to B. So the answer is C. B. Okay. Okay, so now we go to question 8. Question 8. Okay, question 8. Okay, this time it's a coil or loops. The figure shows two concentric loops or coil here, X and Y. Loop X has 36 turns, each with diameter 0.30 meter and carries a current of 5 ampere. Okay, 5 ampere. So find the magnitude and direction of the magnetic field at the center of the loop. Okay, we do question A first. Okay, so the formula for coil is B equals to mu naught and I per 2R. Okay, so we use this formula and substitute the N for X because the question asks only for coil X or loop X. So we can forget for a while loop Y. Okay, so substitute the mu naught 4 pi times 10 to the power of -7. N is 36 turns. I is 5 ampere and the R is radius. R is the radius of the loop. So diameter divided by 2 and the answer is 7.54 times 10 to the power of -4 Tesla. Okay. Okay, now for question B. Okay, don't forget direction. This is the magnitude. The question also asks direction. for direction, you use grip, right hand grip rule. Okay, so you grip the wire, so that means the 4 fingers here shows direction of B, which is upward. The thumb shows direction of current. Okay, the thumb shows direction of current, and the 4 fingers here shows direction of B. Okay, so this is grip rule for loops, for coil. Okay, grip rule for solenoid is different. Okay, the 4 fingers shows direction of current, while the thumb shows direction of magnetic field. Okay, for solenoid. Okay, for coil or loop of wire here, we use opposite. Okay, so the direction of the B of the loop X is upward. Okay, done for question A. Okay, now we go for question B for loop Y. So loop Y has 10 turns, diameter 0.15 meter. So what is the magnitude and direction of the current in loop Y so that the resultant magnetic field at its center is 0? So the B from BX is upward. For the B to be 0, resultant B to be 0, so the other B must be downward. So BY must be downward so that their resultant is 0. Okay, must in opposite direction. So BX equals to BY. This is another condition. Okay, so opposite direction and they have same magnitude. So we can use magnitude of BX, 7.54 times 10 to the power of negative 4 for BY also. Okay, they have same magnitude. Okay, this is the hidden information we can get from here. Okay, for resultant magnetic field to be 0. So you equate them and use the B for wire X and the formula mu naught Ni per 2R. Okay, so now for the magnitude of current, the question asks magnitude of current, not magnitude of B, magnetic field, so current. So you can use this formula to find the current. Okay, so substitute N, 10 turns, mu naught, okay, and then 10 turns, and then the current is what we are going to find, and then the radius is 0.15 here divided by 2, and you cross multiply to get I. Okay, so the answer is 9 ampere. So did you all get this answer or not? 9 ampere? Okay, anyone with the answer can write there in the chat box. Okay. Xiao, did you get the answer? 9 ampere? Okay, done for question B, but don't forget direction. Don't forget, this is a common mistake student makes, always forgot about the direction. So for the direction, you use right hand grip rule. So you grip the wire with 4 of your fingers here, shows direction of the BY, because you grip wire Y. So BY is downward, so you grip this way. Okay, you grip the wire grip Y this way. So the thumb here shows direction of current, direction of current. So it's a clockwise direction. Okay, clockwise direction. Okay, so the answer is in the clockwise direction. Here, mention the direction. Okay, now we go to question 9. Okay, question 9. Involve more than 2 wires. Just now, two wires, now 3 wires. Okay, 3 wires. So what is the resultant? 3 wires sit at the corners of a square, all carrying same current into the screen here. So calculate the magnitude of the magnetic field at point P here. Okay, so the square is 1 centimeter. Okay, the square is 1 centimeter. Okay, so now for the straight wire, we use mu naught I per 2 pi d. Okay, so you grip to find direction of B, so you use grip rule. So for wire 1, you grip the wire here, so that means the direction of B at point P is tangent to the circle of the B here. So tangent to the B is downward, B1. We name this as B1 for wire 1. For wire 2 also the same, you grip the wire. Okay, so this is part of the circle, shows direction of B, so which is in a clockwise direction. So direction of B2 is this way, tangent to the circle. So I3 for wire 3 also the same. Okay, so this is the part of the circle to show the direction of B using grip rule. So the tangent to this point is to the left, B3. We name this as B3. So first determine the direction of the B. Okay, all the direction of the B. So we have B1, B2, B3 comes from the 3 wires. Okay, next we use resultant. B resultant. The questions one, calculate the magnitude of the magnetic field at the corner here at that point P. So the B resultant. So B1 and B3 is the same because they have same distance and same current. Remember question said same current, all carrying currents 2 ampere. So same current, same distance. B3 and B1, look at I3 and look at I1. So the distance is 1 cm, 1 cm here. So they have same magnitude. So we can substitute into the equation 2 and 1 centimeter convert to meter. So the answer is 4 times 10 to the power of negative 5 Tesla. Okay, B1 and B3. What about B2? Okay, B2 is you use Pythagoras theorem to find the distance. Current is the same. So one Pythagoras theorem, so 1 square root of 1 squared plus 1 squared. So we get square root of 2. So square root of 2, so you substitute into there. Okay, so we get 2.83 times 10 to the power of negative 5. So actually got mistake here because 1 cm. So 2 cm, I forgot to convert to meter. Okay, but it's okay. You all, the method is still correct. So only I didn't convert to meter here. Okay, so you all convert to meter. Just follow the procedure. The method is correct. So square root of 2 convert to meter, but I didn't convert here. Okay, so now the B resultant will be, okay, you total up all the BX. So the B2 has 2 component, which is B2 cos 45 degrees and B2 sin 45 degrees. Okay, so is the direction is to the left, so both is negative to the left. So we use vector, so you substitute everything into the equation, so you get this answer. Remember that this one is convert to 2 centimeter here, convert to meter. I didn't convert, but the method is correct. So you find the total of BX and total of BY. So total of BY, we have B1 here plus B2 sine 45 degrees. And let's say downward, we use sine as negative. Okay, so therefore you get this answer, and actually both of them has same magnitude. Okay, you see same magnitude if you calculate. Okay, so therefore the B resultant, you can use Pythagoras theorem, is square root of bx squared plus by squared. So you get this answer, 8 times 10 to the power of negative 5 Tesla. Okay, so for the direction, okay, magnetic field is, this is magnitude for the direction. So bx is to the right, okay, by is downward, shows by the negative sign. So that's mean the B resultant is this way. So the angle, you can use tangent, trigonometric ratio. Okay, tangent theta equals to by per bx. Okay, so it's 1 because by and bx is the same, right? So you get theta 45 degrees. Okay, so this direction. And it's a square, so the direction theta should be 45 degrees. Okay, so let's go to the next question, question 10. Okay, question 10. Hi Alpha, Danish, welcome to physics pre-U class tuition. Okay, now we go to question 10. Okay, a cross-sectional view of 4 cables which carries current is shown in the diagram. Okay, now we have 4 wires here. Okay, the currents I1, I2, I3, I4. Okay, it's given here 16 ampere, 25 ampere, 32 ampere and 44 ampere. So we are going to draw the magnetic fields at point C. Okay, so how to draw? So you use right hand grip rule to draw the direction of B from each of the wires. Each of the wire. Okay, so the first one, I1, start with wire 1. So you grip the wire here. Your thumb shows direction into the screen because cross here shows direction of current into the screen. Okay, so the part of the direction of the B, part of circle to show direction of the B is this one. Green shows by green up here, and this point tangent to this point is B1. We call this B1. So we do the same, but this time this wire is current is out of the screen. So you grip the wire, so it's in the anti-clockwise direction. So therefore direction of B2 is this way. Okay, so direction of for current I3, so the B is anti-clockwise direction or counter-clockwise direction. So this way. Okay, so you draw B3 longer. Why? Because look at the given current here. So I1 is 16 ampere, whereas I3 is where 1 2 3 32. So it's larger value of current. Same distance but larger current. So that means it shows longer line or arrow to show that its value is larger than B1. Okay, B3 is larger than B1 because the current I3 is larger than I1. And for the B2, B4, where is B4 there? So use grip rule. So it's a clockwise direction. So tangent to this point is B4, which you must draw longer than B2. Why? Because for current 44 ampere is larger than current 2. Current 2 is 25. This one is 44. From the B equals to mu naught I per 2 pi D. So I didn't show the formula, but it's directly proportional to current. So the larger the current, the larger the B. So that's why you need to draw B4 longer. So if you draw, make sure you draw its logic logic to the value given. Okay, so this and they are on the same line because it's tangent because this is a square. A square. Okay, so done for question A, draw the magnetic fields. Okay, now we do question B. Now we are going to calculate the magnitude and direction of the resultant. Okay, now we have four B's, four magnetic fields. So the resultant will be B1 and B3, you can total together, total them up. And for B4 and B2, the resultant we name as BR2, the resultant B2 and B4. Okay, so becomes one resultant. Then we combine these two. So we use the formula for B of a straight wire, mu naught I per 2 pi D. Okay, so you substitute the I16 for B1, and distance you can use Pythagoras theorem. So 10 cm here, 5 cm here, also 5 cm. 25 plus 25 is 50. So square root of 50. So 7.07 centimeter convert to meter. Convert to meter. So you get the answer B1. So you do the same for B3. Here B3 is current is 32. So you substitute 32. Distance is the same because it's a square. Okay, so the B3 is 9.05 times 10 to the power of negative 5 Tesla. So the B resultant here, so B1 and plus B3, so you plus them together, you get 13.58 times 10 to the power of negative 5 Tesla. So don't round off too early. So at the end only we round it off. So at least you write it in 3 significant figures also can. Okay, now for B2, we do the same for next resultant. Okay, B2 and B4 here. So you calculate B2, so you get this answer. You substitute I for I2 is 25. Okay, for B4, I is 44. So distance is the same. Okay, because at the center here, it's a square. So distance still 0.0707. the answer is 12.45 times 10 to the power negative 4 Tesla. And the resultant for this one, BR2, so B2 plus B4, you add them, you get 19.52 times 10 to the power of negative 5 Tesla. Okay, so now you get BR1 and BR2. Now we combine these two together for the resultant. We can forget about the wire. We draw the free body diagram. Just use the Cartesian plane also can. Okay, so you convert this as BR1 because we total them up already. So BR1, BR2. And draw logically you draw BR1 shorter than BR2. You see BR2 is 19.52 times 10 to the 5 is longer in magnitude. BR1 shorter 13.58 times 10 to the negative 5 Tesla. So therefore the B resultant is at the quadrant here. Okay, BR, the resultant. Okay, to find this resultant, okay, because this is a square, so angles BR1 made is 45 degrees and BR2 also 45 degrees, yeah, because at the center C, and this BR1 and BR2 is 90 degrees. They are perpendicular to each other. So that means you can use Pythagoras theorem straight away. Okay, use Pythagoras theorem to find BR. So BR is square root of BR1 squared plus BR2 squared. Okay, and this is 90 degrees, right? So can use Pythagoras theorem. So substitute this BR1, BR2 into here and you get answer. Lastly, then only you round it off, becomes 24 times 10 to the power of negative 5 Tesla. And the angle, this is magnitude, and the angle, you measure this angle. So you can use tangent, trigonometric ratio, tangent, opposite per adjacent. So opposite here is BR1 and adjacent is BR2. Okay, so you get theta 35 degrees, but answer it properly. Show the direction is from the positive x-axis here. So 45 plus 35 here, you will get 80 degrees below the positive x-axis. Okay, so this is the answer for direction. So for direction, 80 degrees below the positive x-axis. Okay, so that's the answer. Okay, so we still got time. It's 5:52, almost we have one more question. So we managed to answer one more question. And the C, for the C, state the motion of all wires if the current I1, I2, I3 and I4 of the same magnitude and direction. So this I2 and I3, we change to cross, okay? Cross. So that the questions one same direction. So we all change it to cross or dot. Is up to you, cross or dot. Okay, so the resultant force on each wire have the same magnitude. Okay, why? Because these two wire, same magnitude I, from the formula, same I, same D. Same I, same D, same distance. 10 cm, 10 cm, because it's a square. So that means the resultant force on each wire have the same magnitude and all directed towards the center C. So same direction of current, they attract each other. Okay, attract each other. These two, I1 and I3 also attract each other. I1 and I4 also attract each other. So we name this as F12, F13 and F14. So this one, F14, attract each other. And then is this also F12, they attract each other, these two wires. And this I2 and I4, so these two wires attract each other, same magnitude, F42, F42. And lastly, this one, F113, F13. This one suppose F13, this one F23. So they all have same magnitude of resultant force directed towards the center C. So what happened? The four wires will move towards the center C. Okay, move towards the center C. If the direction is into the screen, also is out of the screen, also the same. The four wires will move towards the center C. Okay, you do the same method. Okay, so now we go to last question, question 11. Hall effect. Okay, related to Hall effect. So a piece of N-type semiconductor with dimension ABC carries a current I in the magnetic field of flux density B. Okay, so constant B. Okay, if the number of electron per unit volume is N, and then determine the Hall voltage of the conductor and its polarity. So given by the answer here A, B, C, D. So which one? Okay, this formula for the Hall voltage is BI per NET. Okay, T is the thickness, I is the current here, B is the magnetic field. So N is number of electron per unit volume. Okay, so E is a charge of electron. So the thickness is A, it's not B and C. This T is the thickness. So thickness is A, so you substitute into the equation here. So you get BI per NET. So A and B is not the answer lah. BI per NET. So either C and D now the answer. Okay, next, use Fleming's left hand rule to determine the direction of force. So B is downward. Okay, B is downward. I is to the left, okay. B is downward, I is to the left. So therefore, the force is towards you, out of the screen or out of the slide. Okay, F is this way. So that's mean the electron will accumulate at this side because this is the N-type semiconductor. So the majority of charge carrier for the semiconductor, N-type semiconductor is the electron. So therefore, the electron will accumulate at one side of this conductor, of this semiconductor. Okay, this way. Okay, so therefore, so from top view, you can see like this lah, from top view. So current this way, because of N-type, the charge carrier is electron. So all the electron will accumulate to one side here. Okay, because of this force. If it's a P-type, so the positive charge, the holes will accumulate at one side here. Okay, because it's the P-type. So how to know the direction of force? This one, because from top view, so you use this direction. So cross means magnetic field into the screen. Current is this way. So the force is upward. So that's why both animation here shows that the charge carrier, okay, move to the top. Okay, move to the top. Okay, so that's the difference between N-type and P-type semiconductor. Okay, so the answer is D. So the front surface here is this one. Front surface, back surface. Front surface is negative because electron accumulate this. Accumulate here. Okay, accumulate here. N-type semiconductor. So that's the answer. And therefore, you must also know Hall effect. Okay, so Hall effect, there are 4 steps of Hall effect phenomenon. Okay, you must know what type of the metal used. Either it's a conductor or semiconductor. Okay, whether it's a conductor or semiconductor. If conductor, the charge carrier is electron. If semiconductor, N-type electron. For the P-type will be holes, and for P-type is holes, and for the N-type semiconductor is electron, the majority charge carrier. Okay, so for conductor, the electron, the charge carrier is electron. So when you apply the magnetic field, so using the Fleming's left hand rule, okay, the B is upward in this case. So determine direction of B and direction of the current. Electron flow this way, but current this way. So it's into the screen. Okay, into the screen is cross lah, cross. So direction of F is to the right. Okay, so all electron will accumulate one side of the conductor. In this case, conductor lah. Just now semiconductor. This is conductor. And lastly, the negative side here will be negative terminal, and the other side will be positive terminal. So when you join the across, when you put the voltage, measure the voltage across these two sides, you will get the voltage which is called Hall voltage. Okay, Hall voltage. across the two sides of the conductor. Okay, current flow here, but the Hall voltage is across these two sides of the conductor. This is called Hall effect. So this is the simple 4 steps to explain the Hall effect. Okay, to be remembered. Okay, so now we comes to the end. I leave this question for you all to do, and you can write the answer at the comments below this YouTube video, and I will check later your answer. Okay, so that's all for today, and I hope you all may get benefit from this video. And we have achieved our learning objective today, and I will pass the session to our moderator, Madam Nun. Okay, Madam Nun.
Okay, thank you so much, Madam Rosmaya. With God's grace, we have reached the end of today's lesson. Congratulations to those who are able to follow our lesson from the beginning till the end. Before we end our session for today, I will announce the 2 last digit code for the credit claim. Okay, please listen carefully. The last digit code is 14. Okay, number 1 and number 4. 14 actually. 14. Okay. So all of you, please stop posting your comment for a while and click the subscribe button and activate the icon bell so that you will not miss the next class lesson. Then if you find the lesson was beneficial, click like and share to your friends on your social media. Spread and share the goodness. Once complete, type done on the chat box before the certificate link given as a token of thank you for your dedication in joining the free online class today. Okay, I will put the certificate link for all of you. Wait. And also the link for the credit claim. Okay, you can fill in the form at the end of this after this. Okay, wait. Okay, so this is the link, all the link. Okay, the related link. So please take note, the link will end half an hour after this live. Make sure to use the EDD email and MOE email only to log in. Incorrect email use will not be entertained. If you haven't got one, please apply the email, which the link to apply the EDD email is already given in the chat box. Okay. If you wish to get more information on the online class, you can go to the www.academyyoutuber.com. And those who haven't joined EDD Junior Telegram, please do so. Once again, I would like to thank all students for joining today's class. You are awesome. Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all teachers throughout Malaysia for all the students throughout the country. Thank you for being a YouTuber Academy supporter too. I think that's all for now. See you in another lesson. Remember the hashtag bermula percuma, selamanya percuma. So, Assalamualaikum warahmatullahi wabarakatuh. Stay safe till we meet again next week. Same day and same time. Okay? Bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau.
Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.